Hi everyone. Now we are going to discuss about the topic tree. So what is tree? A tree is a connected graph without any circuit. So here V1, E1, V2 is a graph. This graph has no circuits and it is a connected graph. That means at least one path between every pair of vertices is a tree. Therefore this tree is a connected graph. So a tree is a connected graph without any circuit. So now we're going to discuss about the properties of tree using some theorem. There is only one path between every pair of vertices in a tree. So a tree, suppose only one path is possible in a pair of vertices, it is a tree. You prove this. Let T be any tree. So what is tree? If T is a tree, then T is a connected graph without any circuit. So T is connected. There must be exactly one path between every pair of vertices. Suppose there are two paths between two vertices A and B. What is union of these two paths? The union of these two paths will form a circuit, which is contradiction. Why? Because tree is a connected graph, but circuit is not a connected graph. Therefore, a tree has only one path between every pair of vertices. Therefore, it is a tree. Therefore, T has no circuit. So, therefore, there is only one path between every pair of vertices in a tree T. The second property, if there is in a graph G, there is only one path between every pair of vertices, then G is a tree. So one path between pair of vertices, so definitely it must be a tree. Let we prove this. Let us assume that for every pair of vertices, there must be only one path between them. So we need one more. If G has no circuit, then it is a tree. Suppose G has a circuit. What happens? Let A and B be two vertices in the circuit gamma. This implies there exist two different paths A and B. So which is contradiction because there is no circuit in the path. So G has no circuit. So G is G has two vertices. The two pair of vertices has a path and it has no circuit. Therefore G is a tree. Third one, prove this. Any connected graph with n vertices and n minus 1 edges is a tree. We prove this. Let G be a connected graph without any circuit. Let G be a connected graph with n vertices and n minus 1 edges. Our assumption is G is connected graph. Now we prove that, or we take the claim, G has no circuit. If G is connected and G has no circuit, then it is a tree. But our aim is, if G is connected graph, if G has no circuit, then it is tree. Now we prove, suppose G has a circuit containing m vertices. If a graph has m vertices, so definitely it has m minus 1 edges. Therefore, the circuit has m minus 1 edges. So, but it is not possible, but we prove. Let us name the remaining n minus 1 vertices v1, v2, etc., vn minus 1, and let us fix a vertex u in this circuit. Since G is connected, there is a path to u and v1. So that path is connected by the edge e1. Incident on v1 is a path. So u is again connected to v2. U connected to v3. U connected to vn minus m. So how many edges? E edges is connected. So m edges connected all this. Already in the whole graph, already it has n minus m edges and m edges connected in the remaining edges. So n minus m plus m in the total edges of G. So cancelling these to n. So which is contradiction because the graph has n vertices and n edges also, but it is n vertices, n edges is a circuit. So it is contradiction. So G has exactly n minus 1 edges. Therefore, G has no circuits. Hence, G is a connected graph and G has no circuits. Therefore, G is a tree. Thank you.